How are we doing, class? Today we're going to be going over how you can identify aldehydes and ketones because they both have that carbonyl group that we looked at in the last lesson, but we need to be able to distinguish between the two. But before all of that, you already know what to do. The retrieval grid, full sentences, have a go at them. So this first question is asking you, what is the name of this chemical? And it's NaBH4. You should say it's sodium tetrahydroborate 3. The next question, what is the formula for potassium dichromate? And potassium dichromate is K2Cr2O7. And the last one, what does heterolytic fission mean? Heterolytic fission is the breaking of a covalent bond and both electrons go to one atom. So hetero, remember, means different. So you have two different species coming out of that fission reaction. As opposed to homolytic fission, which will mean you've got the same species coming out of that interaction. And these are the specification points that we're going to go over today. It's going to be a relatively short video. And make sure at the end that you can identify and tick all of these off. So let's start this off. We've got this molecule here called hydrazine, and we've got this chemical that can be added to a benzene ring, and that is when we remove one of the hydrogens from it, we've got N2H. So bear that in mind. Hydrazine is actually N2H2, but when we remove a H from it, we can add that hydrazine group onto a benzene ring. So now we have this molecule over here. Have a go at these challenge questions, full sentences, okay? That first question is asking you to write a chemical formula for this, and that should be C6H6N4O4. And since you've got the chemical formula, the molar mass of this should be pretty simple. Just look at your periodic table, and that will give you 198.14 grams per mole. And now thinking, you may have some difficulty with this next question, but if you was to have a guess at the name of this chemical, we'll see that we have two nitro groups. So if we imagine that the hydrazine group is position 1, so we've got a nitro group in position 2 and 4. So we've got 2,4-dinitro. And we know that in this situation, the benzene is going to be the substituent. So we need the phenyl in that name somewhere. That means altogether that's 2,4-dinitrophenylhydrazine. Or we can abbreviate that to 2,4-DNP. And 2,4-DNP can be used to identify and detect a carbonyl functional group. So we can use 2,4-DNP to see if we've got an aldehyde or a ketone because they both have that carbonyl group. The problem with this is that friction can cause this molecule to explode. So it's very unstable, and we actually need to store it in a very special reagent. And that reagent here is Brady's reagent. Have a go at these challenge questions. And we can see that the two chemicals that 2,4-DNP is dissolved in Brady's reagent is methanol and sulfuric acid. And if you ever ask, why do you need to dissolve 2,4-DNP, 2,4-dinitrophenylhydrazine? It's what we saw before. It's explosive as a solid, so we have to dissolve it in methanol and sulfuric acid. And if this reagent detects a carbonyl group, there will be a color change, as there always usually is. And Brady's reagent, it forms an orange precipitate when it contacts that carbonyl group. So the solution goes orange and it's a precipitate. So let's look at this actual reaction. It's a condensation reaction. So this reaction is a condensation reaction, and we've got our 2,4-dinitrylphenohydrazine on the left hand side, and we've got a carbonyl group, and we're representing the two ends of it with X's. Try guess what's going on here. Draw your reactants and then draw what your possible products will be. My clue here is that it's a condensation reaction. I'm even labeling and highlighting some things on here. You should be able to work this out. So have a go. When we're using that word condensation, we know it's got something to do with water. And I've highlighted the two hydrogens on that nitrogen on the 2,4-DNP, and also the oxygen on the carbon. And if it's a condensation, we're probably going to remove that water molecule. So then we just attach the carbon directly onto the nitrogen and we get rid of that water molecule. So this is the actual reaction that happens when 2,4-DNP reacts with a carbonyl group. Have a go at this challenge question now. So the challenge question here, complete these reactions, and I've given you the chemical formulas for some of the unusual ones. So we've got 2-methylpentanthreon reacting with hydroxylamine, and we've got phenylethanol, and we've got the formula there, reacting with hydrazine, and we've also got that formula there. So let's first have a go at the first reaction. So the 2-methylpentanthreon and the hydroxylamine. So based on the chemical formulas I gave you, you should be able to work out that this should be the reactants. And it's a condensation reaction, just like before. We're going to get rid of the water molecule. So that's the two hydrogens on the nitrogen and the oxygen on the carbonyl. And then the nitrogen is going to attach directly via a double bond to that carbon. And this should be your product there. And then the next one. So we've got these two reactants. Again, it's going to be a condensation reaction. We get rid of two hydrogens on the nitrogen and we'll get rid of the oxygen on the carbonyl. And the nitrogen is going to attach directly to the carbon via a double bond. And that is your reaction. Okay, so testing for the carbonyl group. You need to know these steps. So just write these down, memorize it, and I've got some visual aids to help you out. First thing you need to do, you need to add 3 centimeters depth worth of 2,4-DNP into a test tube. Then you're going to add 3 drops of your unknown using a dropping pipette. If no crystals form, add a few drops of sulfuric acid. And when an orange precipitate forms, that's a positive test for your carbonyl group, okay? And this is what it looks like. You can see in the left-hand side, we've got that orange. Then we add in a few drops. So you can see that the orange precipitate already starts forming. And then later on, you see that very, very cloudy orange looking color there. That is your positive test. I've got a question for you now. Why can't you use 2,4-DNP to identify a ketone? Well, the reason why you can't do that is because the carbonyl group is on both aldehydes and ketones. So you won't be able to say definitively that this is a ketone. We need another way of distinguishing between aldehydes and ketones because the 2,4-DNP just tells us we've got a carbonyl. And that brings us to Tollen's reagent. And I've got the ingredients of Tollen's reagent just in this box here. You already know what's going to happen. Have a go at these challenge questions. The first one, pretty straightforward. Name the 3 chemicals in Tollen's reagent. That top one there, we see a silver ion and we see a nitrate ion, so obviously silver nitrate with CnH2. H3, which is ammonia, and we see NOH, which is sodium hydroxide. So the three chemicals in Tollen's reagent: silver nitrate, ammonia, and sodium hydroxide. This test is also called the silver mirror test. What do you think is happening? I've given you that clue of oil rig there. It's called the silver mirror test. What do you think is happening? And I've given you oil rig. To get silver atoms, which will form that silver mirror, we need to reduce that silver ion. So the silver is reduced into silver atoms, and those silver atoms coat the lining of your test tube. And this one's asking you which carbonyl would give a positive test for this and why. This next one's a little bit trickier, but what you should have said there is that you would test for aldehydes because they are more readily oxidized. So that's one of the differences between ketones and aldehydes. Aldehydes are more readily oxidized, and it's because of that hydrogen that's next to the carbonyl group. And if you want a picture of what that silver mirror test looks like, it looks like this. So testing for aldehydes. Again, memorize these steps. You add 3 centimeters depth worth of silver nitrate into a test tube. Then you're going to add sodium hydroxide onto a brown precipitate of silver oxide is formed. So you form a brown precipitate. And then what you're going to do is add dilute ammonia until the brown precipitate dissolves. Now you've got your Tollen's reagent. So now to test for the aldehyde, you add 2 centimeters depth worth of your unknown, add an equal amount of Tollen's reagent, leave it for about 15 minutes at 50 degrees Celsius, and a silver mirror, like the picture I showed you before, will indicate a positive test for an aldehyde. Let's look at this. Tollen's reagent causes the reduction of silver 1 ions and the oxidation of the aldehyde into the corresponding carboxylic acid. Show these 2 equations. Use propanol as your aldehyde. So we've got 2 reactions we need to show, okay? Tollen's reagent causes the reduction of silver ions, so we need to show that equation, and the oxidation of the aldehyde into its corresponding carboxylic acid. I would like you to show these 2 equations, and the aldehyde you're going to use is propanol. Well, the first one's pretty straightforward. It's just a half equation. We've got our silver ions and they're going to be reduced, so they're gaining electrons. Rig means reduction is gain, and that gives us silver atoms. And then the next one, we're oxidizing the aldehyde into the corresponding carboxylic acid. So we've got propanol, which is our example, and we're making propanoic acid. And as I said before, the reason why this test works is because the carbonyl containing carbon has a hydrogen attached to it, which makes it more readily oxidized. And that's the lesson for this week. So as I said, it's a pretty short one. So look at your topic checklist, which ones you can tick off, which ones you can't tick off. That's the one that you need to come to class being willing to discuss your misconceptions, and I'll do my best to alleviate those. So catch you next week. Revise, revise, revise. Take care.